Okay, in this video, I wanna show you how to sketch a graph of a function if we know the information of the derivative of that function. And we are going to do this by following this get line. Okay. If we have function that is continuous on some interval, on some open interval I, and the point x equals c is on that interval, then if the derivative is positive, then the function is increasing. If the derivative is negative, the function is decreasing. If the derivative is zero, then we're gonna have a horizontal tangent line at the point when the derivative is zero. And if the derivative changes from positive to negative, the function gonna have a local maximum. When the derivative changes from negative to positive, then the function gonna have a local minimum. Okay, let's practice this by using this example. This problem says we want to sketch a function that is continuous on the interval from negative infinity to positive infinity, and the function satisfies the following conditions. One is the derivative is positive on the interval from negative infinity to 2, from 4 to 7, and from 7 to infinity. The derivative is negative on the interval from 2 to 4, and the derivative is undefined at x equals 4, and the derivative is 0 at x equals 2 and x equals 7. Okay, the first thing I'm gonna do is to draw a number line, and then I'm gonna write down all these informations. I'm gonna write down all these informations of the derivative on this number line. So we have so first I'm gonna divide this number line by using these numbers 2, 4, 7. Okay. Since the derivative is positive on the interval from infinity to 2, 4 to 7, from 7 to infinity, so the derivative is positive, positive, okay, and it's negative on the interval from 2 to 4. Okay. And what else? The derivative is undefined when x equals 4. So the derivative undefined. And the derivative is 0 at x equals 2 and x equals 7. Okay, after I have finished this, then I need to think about how can I translate this information. Now these informations, they are the information of the derivative, right? I need to think about how can I translate this information into the information about the function, fx. So when the derivative is positive, the function gonna be increasing. So the graph of the function gonna be like this. It goes up, right? So the function is increasing. Okay, increasing. And when the derivative is negative, the function gonna be decreasing. Okay, and for the when the derivative is undefined, we said on the graph we're gonna have a sharp corner. And when the derivative is 0 on the graph, we have a horizontal tangent line. Okay, after I found this information, now we can use them to sketch the graph of this function. So I know, okay, since the function is increasing from negative infinity to 2, so before 2, the graph of the function gonna the graph will rise. Yeah, will rise. So like this way. Okay. Now remember, since we are not given that what does the function equal when x equals 2, right? We don't know what does f of 2 equal, so therefore there's no way for us to graph that. So we can assume a point. We can assume, say like here, I assume f of 2 equals 8, right? Now after x equals 2, the function is decreasing from 2 to 4, so the graph goes down after 2. And at x equals 2, the graph has a horizontal tangent line, so it looks like this. Okay, so here I have we can draw a horizontal tangent line. Okay, now from 2 to 4, the function is decreasing, and from 4 to 7, the function is increasing again. Okay. Now, because at x equals 4, the derivative does not exist. So when x equals 4, the graph gonna have a sharp corner. So here we should have a sharp corner at 4, at x equals 4. Okay, let me do this again. Okay. So from negative infinity to 2, the graph goes up, and at 2, after 2, the graph goes down. Okay, and at x equals 4, the graph has a sharp corner. Okay. Okay. Another thing is at x equals 7, since the derivative is also 0, so the graph also has a horizontal tangent line. So at 7, we know we're gonna have something like this. So the graph has a horizontal tangent line. So go here, and from 7 to infinity, the graph also increasing. So so it's gonna be like this. Okay. All right. Now let's summarize this. So from negative infinity to 2, the graph is increasing. The function is increasing. At x equals 2, we have a horizontal tangent line at 2. Right. And from 2 to 4, the function is decreasing, and at x equals 4, since the derivative does not exist, so the graph has a sharp corner. And from 4 to 7, the graph is increasing again, and since at 7 we have the derivative equals 0, so at 7 we have this horizontal tangent line, and from 7 to infinity, the graph is continuing to rise. Okay, so this is how to sketch, how we can sketch the graph of function using the information of the derivative. Okay.